Hello and welcome to this ICEM Surf tips and tricks video. This is Nick McFerrin from the CATIA Design IPS team. This video was put together with support from Virginie Dubois and Didier Corbin, and we're going to take a look at the Profiles command, most used options. Starting with the simple spine with two profiles, we simply pick the spine, Profile 1, Profile 2, and finish selection with the middle mouse button to get the preview. And if you're happy, an OK produces the result. This next example is quite similar, but with an extended spine. See what happens when the spine extends beyond the profiles. The preview gives us a clue of what's going on, and OK confirms the result. Now let's take a look when we use multiple profiles. We can pick as many profiles as we like. The linear shape option joins the profile ends with straight lines. Local shape merges the profile shapes together, going up to the maximum allowable order specified in the approximation tab. Smooth shape smooths out the linear bumps, and the cleanest shape is produced with the global shape, which gives us the best result in this case. Now let's take a look at the profile orientation options. Here we have one profile, one spine, and a second curve option. Looking at parallel to plane, notice that the profile is always kept parallel to the plane. Switching to radial to spine curve, see what happens to the profile. The profile is moved normally to the spine curve, rotating as it goes. With the second curve option, the orientation of the profile is controlled by a second curve as it slides down the spine. This is useful for better control of the result. Now let's have a look at the axes alignment options. Here we have a complex spine passing through X, Y, and Z directions with a curved profile. If we stick with the radial to spine option and look from the top view, see what happens. It looks okay from here, but if we turn the model a little bit, you can see that it's crossed over itself towards the far end of the spine. The profile is following the spine like a roller coaster. To fix this issue, we can use the vector option. We can define a vector, in this case the Z direction, to control the orientation of the profile. The profile will remain normal to the Z direction. This is what I call the cable car effect. Now let's look at the attach point and curve options. Pick your spine and profile options, and then under the Advanced tab, you can find the curve and attach point options. Here, picking the attachment point as the end of the profile attaches the profile to the spine. Making use of the curve option and picking the second curve will now make the profile follow the curve. But the normal of the profile is still defined by the spine. Remember, we are using the radial to spine option. With the curve selected, if you redefine the attachment point, the profile will be generated on the curve. Again, the normal is still being defined by the spine. Let's now look at using a surface for a reference. Here we have a profile and a spine as normal. As you would expect, it produces this result on the first click. But then if we define an attachment point, the Profiles command will move the result to sit on the spine at that attachment point. But then if we change the option to a sliding surface, we can now pick a surface as a reference. And then the attachment point is moved down onto the surface, so the profile produces the result sliding across the surface. Now we're specifying a sliding vector. This will rotate the profile according to the direction of the specified vector. Here the profile is rotated, so the tangent vector is aligned to the surface at the start of the projected spine. Let's look at the Advanced Rotate with a Limit Curve option. So we pick the spine and the profile, and then we also pick a limit curve. This option rotates the profile so that it touches the limit curve as it passes down the spine. Similar to limit curve, we also have rotate with surface tangent. We pick a spine and a profile, and we can also pick a surface reference. Under the Preview tab, to see the right preview, untick Rotate Profile. Now you can see it's been rotated around until it touches the surface at a tangent point. If we press OK, the result is given to us, as well as a curve to track where the profile is touching the surface. Now if we change the option to rotate to surface with a point, the end point of the profile is automatically picked as the attachment point, and the profile is rotated so that the end point tracks the surface. The curve is still produced. We can also define any limit point on the profile just by picking a location. Here I'm picking near the end of the curve. And the profile is rotated, so this location is now the one tracking the surface. This concludes our video on the Profiles command most used options. I hope you found it useful and interesting. Please remember to come on over to the CATIA Creative Design and Styling Experience community, where you can ask questions, share ideas, and meet the experts as we talk about creative design. Thank you.